Welcome to this Tech Insights executive briefing. Huawei's latest Kirin 9030 is raising a critical question across the semiconductor industry. Has SMIC reached 5 nanometers? Our teardown and structural analysis point to a clear answer. Not yet, but this is a meaningful step forward. In context, the Kirin 9030 comes from Huawei's Mate 80 Pro Max, its newest 5G device. Earlier chips like the 9000S and 9020 were built on SMIC's N+2, widely seen as 7 nanometer class, achieved without EUV. Now, the focus shifts to the N+3, a node some are calling 5 nanometers. But SMIC has never officially claimed that. So what does the silicon actually tell us? The evidence seems to show that at first glance, the die size is unchanged at 137 millimeters squared. But it packs more, including at least one additional CPU core. That signals progress. However, compared to leading 5 nanometer chips, it's still significantly larger. 57% bigger than Apple A14, 28% bigger than Snapdragon 888, 11% bigger than Exynos 2100. So while scaling is happening, it's not at the 5 nanometer density levels. Looking at the metrics, our measurements show a 57 nanometer gate pitch with a 32 nanometer fin pitch and 120 million transistors per millimeter squared. That's an improvement over SMIC's previous node, but it still trails TSMC and Samsung 5 nanometer class processes. This aligns closer to 6 nanometer class density. The real story here, and the key takeaway is, SMIC is pushing DUV lithography to its limits. We're seeing metal pitches around 30 nanometers, below the typical DUV capabilities. That implies advanced multi-patterning techniques like quadruple patterning. It's an impressive technical achievement, especially without EUV, but it likely comes with some trade-offs, such as lower yields, higher costs, and greater complexity. The bottom line is the Kirin 9030 confirms that N+3 is an evolution of SMIC's 7 nanometer platform. It is more advanced, but it's not a true 5 nanometer. This isn't parity, it's strategic progress under constraint, and that may be the most important signal of all. For deeper analysis, see the full Tech Insights report, available at techinsights.com.